Welcome to this video, great to have you here. My name is Maximilian and in this video we'll talk about servers, or to be precise, not about servers. As you probably know, if you want to run your web application in, well, the web for other people to reach it, you need a server where your application runs on, right? The single machine in the internet which can be reached via its IP address or a domain, obviously. So that is what you know. The issue with that approach is that the server has to be up all the time. If you get unexpectedly much traffic, it might go down or you might need to add more servers. On the other hand, if you don't get enough traffic, you're paying for server capacities you're not using. And you have to manage these servers, you have to keep the operating system up to date and all the software on the servers. And it doesn't change whether you're doing that in the cloud or on-premise data centers. In this video, I'm going to show you a little solution or an idea, a concept you can use to run your application without managing servers. We're going to use AWS Lambda for that. Let's take a closer look in this video. So, welcome. What is AWS Lambda and what do I mean with running code applications without running any servers? Well, obviously, you're still going to need servers. There still has to be a place in the internet where your application can be reached. But AWS offers a service, or actually a couple of servers, which work together really well, which allow you to provide your code on demand. So that if you get an incoming request, you execute a certain code, do something, whatever your business logic is, possibly also reach out to a database and return something, and then that is it. You don't have to keep any server up or anything like that. AWS will manage that, will make sure that your code can execute, but you don't have to take care about providing it all the time or providing a server all the time. As I said, I'm talking about AWS Lambda, which is AWS code on demand service, you could say. Let's take a closer look. I'm already logged into my AWS console, and I will say this right away, what I'm showing you in this video can be done for free. All these services here have a very generous free tier, which doesn't even end after 1 year. But as always, it's best if you check the pricing page, because I can of course only say this at the point of time recording the video, not in general for all times, because unfortunately I can't see into the future. So let's go to the console, and here we can either simply search for Lambda, and we have it here, or choose it here from the compute section. And that already is interesting. If you watched my other videos, you saw that EC2, which we use to spin up servers, also sits in the compute section. So both services seem to be usable for similar tasks, and they are. We can spin up an EC2 server and run our code on it, and we can use Lambda to run our code. So let's click on Lambda. Now, I'm taken to the Lambda console here, and I got no functions, as it's called here, as of now, which is why I'm on the Getting Started page. So let's click Get Started Now. And here we now can create a new function. Now, Lambda is a service where we can basically provide functions which encapsulate the code we want to run upon certain triggers. Now, here I have to create a new function because I don't have any, and there are a couple of presets you can choose from. Now, I'll go with the blank function, and in the next step, we actually have to configure a trigger. And this is the interesting part about Lambda. As I said, it's code on demand, so to say. It doesn't run all the time, it runs when it needs to run. And who determines when it needs to run? Well, a trigger, triggering that function. So basically an event which executes that function. And that is what Lambda really is about. It's this event-driven approach of running your code. Now you can assign a trigger by clicking on this square here. And as you can see, there are a couple of AWS services which can trigger Lambda. Now, you could, for example, trigger it whenever you upload a file to the Simple Storage service, to S3, which is the cloud storage service of AWS. You could react to that upload and then do something upon it. For example, you could write a Lambda function which reacts to file uploads, checks if the file is an image, and if it is an image, transforms it, creates a thumbnail based on that image. That would be a typical task. Now, in this video, I want to show you how you can actually use Lambda together with another server to create an API you can use. An API which is always there and which reacts to incoming events. So for that, API gateway sounds right. But actually you don't choose it here. And the single reason for that is that once we use that other service, API gateway, there we can also set up which action should get triggered whenever a request is incoming. And there we will forward the request to Lambda. And I know this is kind of strange. It simply is how it is though. So don't assign a trigger here, leave it empty and click on next. Now on this page, you can configure your function a bit more. For example, give it a name. And I'll name it simple API test, but of course the name is totally up to you. You can add a description, and now here, interesting, you can pick a language in which you want to write this function. As you can see, there are a couple of supported languages, C#, Java, Node, no PHP. So if you plan on writing this in PHP, unfortunately, that won't work. I'll stick to Node 6.10 for my case here. And then here, you can actually write the code. No worries, if you got more complex code, you can also upload a zip file with the code. But for this demo here, we'll stick to this. So here we see we got a callback that is using that third argument, which gets passed to that function. And we pass 2 arguments here. And we could write more code here in the highlighted section. Now, without diving too deep into that, what's generally happening here is we got 3 arguments which are automatically passed to that function, event, context, and callback. Event will be the event data. So back to that image upload example, that would be data information about the uploaded file. Later, when we hook it up to our own incoming request, that will be request data. Context gives us information about the context of this function. For example, how long it is already running. And callback is actually a function which we can execute, as we do here, which we need to execute once we are done. This will then inform Lambda that we are done. It will return some response and shut the function down. And the callback again takes 2 arguments. The first one is the error argument. So you can pass an error message or error object here. Or, as here, you set it to null to indicate there wasn't an error. And instead, the second argument then becomes important. And here you simply pass back your success data. In this case, a string, but that could also be an array, an object, whatever you want to return once this function successfully finished. I'll leave everything as it is and scroll down. Here you can configure even more, and I won't dive too deep into that. What is important though is the role. Lambda executes code. And if you plan on interacting with other AWS services here, for example, storing a file on simple storage service, you need to give Lambda the right permissions. Watch my IAM video to learn more about permissions and this identity and access management. So here you can assign a role and you can choose either an existing one or create a new one from a template. Here I'll give it a name, basic Lambda role. You could now choose some policy templates, but I don't need any special templates. There is one policy which is always attached though, some permissions which allow Lambda to write log files, which of course is useful for debugging it. With this setup, we can scroll down, assign tags to track Lambda on our builds and so on. And under advanced settings, here we can assign the memory Lambda should be able to use for running our function. And of course, the more memory you use, the more expensive it will be. Or as I said, there is a generic free tier, but you will eat that up more quickly if you, use more memory for your functions. So definitely inform yourself about the pricing. And you can specify a timeout. The maximum here are 5 minutes. Can't go above that. After 5 minutes, your function will shut down, no matter what. So very long running processes can't be handled with that. But 5 minutes should be a decent amount of time for most actions. Here, I'll ramp it up to 10 seconds to have a little bit more headroom for our function. You will get charged, or your free tier will get eaten up on a per 100 millisecond of runtime basis. That is important to know. But of course, your function needs the time it needs. Just make sure to set a timeout which isn't over long, because if you for some reason have an infinite loop in your function, you certainly want to cancel before 5 minutes are, done, because that will be more expensive, and having a shorter timeout prevents you from, eating up your free tier or paying too much just because of an error in your code. The other stuff here is more advanced. We can ignore that and click on Next to review all our settings and hit Create Function. And with that, we did create our function. It doesn't do that much, and we didn't attach a trigger, but we do have some code we can execute. And actually, we can see this by clicking on Test. Now we're asked to pass some dummy data into the function, some test event. Here it's an object with 3 keys and 3 dummy values. We could change this, but our function doesn't really use the incoming data, so we can just click Save and Test. And now it's executing it, and here we see hello from Lambda, which of course is this string. This is our first function executed, and you're probably asking yourself, well, that's nice. We can execute some code here in the cloud. Awesome. I can do that on my computer too. Where is the part without managing servers? Well, it's already here. We didn't spend or set up any server. We didn't configure any server here. We're not choosing an operating system or a capacity, no CPUs or stuff like that. We only chose the memory this function is able to consume, and that's it. Still, however, we wouldn't be able to trigger that function via HTTP. We can't send a request to that function, trigger it. That, however, is what I want to do. And for that, we need another service. And that service is called API Gateway. Now, you can either find it here under Application Services, or as always, you search for it. Now, API Gateway allows you to create a RESTful API. And that is an important point. This Lambda thing is mostly useful for creating APIs when it comes to handling HTTP requests. We also have the other triggers like file uploads, where it's very useful too. Data analytics, also a useful use case. But when we talk about handling HTTP requests, it works the best if we combine it with API Gateway, which, as the name implies, allows us to create APIs. If you plan to host your next Node Express application on Lambda, that's actually possible, and I have a link in the video description which shows you how that works, but it's not super straightforward. It's kind of a workaround and not the cleanest solution, but certainly doable with certain limitations, also mentioned in the link in the video description. But these limitations might not matter to you, and if they don't matter, you have a very cheap way of hosting your Node Express application. Here, however, let's create a REST API, and the goal is to handle incoming requests to our endpoint, execute the Lambda code, and return a response. Therefore, on API Gateway, let's click Get Started, and let's click New API here. Give it a name like Simple API, whatever you want. Optionally, give it a description and hit Create API. And now you're in this console where you can conveniently create an API by clicking on Actions and then adding resources, which are your URL segments, and methods like get and post, which you want to handle on the different segments. So we have a Lambda function which returns as a string, right? So let's click Create Resource here. And here, I now will give this any resource I want. I wouldn't even have to do that. We have this root resource, just slash, but I'll add simple test here, /simple test. That is in the URL what I later have to call. We can also enable a course here to automatically add an options object to handle pre-flight requests, but that again is advanced, and all I want to do is send a GET request, for which I won't need that. So let's hit Create Resource with that. And we have a simple test resource. Now, the path to that would be the path to our API, which we will see later, so the URL of our API, /simple test. This isn't that useful though. We want to handle GET requests, and therefore we have to specify that we plan on doing that. So let's click Action, Create Method. With this segment, with this path, this resource selected, that's important. Now in this dropdown, you can choose all types of HTTP requests you want to handle. Let's choose GET here. And with that, we created this new endpoint. Now we have to decide what do we want to do if a request reaches this endpoint. We can execute a Lambda function, which sounds like what we want to do. We can forward this to another HTTP endpoint. We can set up a mock endpoint, which is a dummy endpoint, simply allowing us to return some dummy data. Or we can trigger some other AWS services. Now, I want to trigger an AWS service, but that service is Lambda, and therefore let's choose Lambda function. And what this will do is that whenever a GET request, hits this endpoint, it will automatically execute that Lambda function here. For that, let's choose the Lambda region. And for me, that's US East 1. As you can see here, I'm in North Virginia. And there I got my simple API test. Simply type some letter of your Lambda function name and you should see that drop down. Now, this Use Lambda proxy integration checkbox would allow you to forward the full request as it is to Lambda. Now, I won't do that here, though I could, but I will leave this unchecked and hit save. And now we're prompted to give API Gateway the permissions it needs to execute Lambda. And of course, we want to allow that, so let's hit OK. And this now connects this endpoint to Lambda. Now, the whole thing on the right here looks really complex. And I do explain this in great detail in my full serverless course, which is linked in the video description and which I linked earlier in the video. So if you want to learn more about this whole serverless thing in general, about Lambda, API Gateway, and a couple of other great services, definitely check this course out. It's very useful for diving deeper into that. For this video, I'll ignore this and only give you the basic information which you need to understand that. This basically, the cycle you see here, is like the funnel our request and response travels through. The method request is like the gatekeeper. Here, if you click on it, we could set up authorization or validation to block incoming requests if they don't fulfill certain criteria. Here, no criteria is set up, so all requests are allowed to continue. In integration request, we can then transform incoming requests. Here under body mapping templates, we could set up templates to retrieve certain data fields from the incoming request body. So if our request body is a JavaScript object which holds data, age, and height, and we only need the height in the Lambda function, we could set up a template here which does this extraction. If no template is set up, the complete body is passed through, as we can see here. So I'll leave this default of passing the whole request body. Then here's our endpoint. This is the Lambda function which does something with the incoming event or not. Our currently active function doesn't do anything. It just returns hello from Lambda, but that's fine too. It gets the request, and if it decides to not do anything, that's okay. Then we get back a response. In our case, remember, that's just a string, hello from Lambda, and that's fine. It's text, that is okay. Integration response then is the opposite of integration request. In request, we could transform the request. So take something from the incoming request and decide what we want to pass to Lambda. Now we're getting something from Lambda, and in integration response, we can actually also set up body mapping templates as well as header mappings to configure which headers and which body we want to return in our response. So we could transform the response we get back from Lambda here to have the exact format of the response we want to send back to the client. And then we have the method response here. This is not like a gatekeeper because we have to send back a response, so we never block that. But here we can define how our response should look like. And whatever we set up here regarding status code as we support, or regarding headers each status code response should have, whatever we set up in method response gives us the blueprint we can work with here in the integration response in this transformation. So if we want to assign a certain header, we have to set it up in method response before we can use it here. And if that's all super confusing, no worries, that is not really that important right now. The current setup will forward the request to Lambda and then forward the response unchanged back to the client. This is what happens, and keep in mind our response simply is a string. So what we can do with that is we can try it out. And for that, let's click Actions and then Deploy API, because right now it's not active. We can't reach it from the web. If we hit Deploy, we can make sure we can reach it. We have to choose a stage for that. Your API can have multiple stages, like a development stage, a production stage, a V1, version 1, and V2, V3, whatever you need stage. Here, I'll create a new stage and name it Dev for development. You can give this stage a description and the whole deployment, so that you say in this deployment I added the get method so that you can keep track across all your deployments because you are able to roll back and so on. I'll leave it empty nonetheless and hit deploy. And next, you're presented with an URL which allows you to reach your API. However, that is just the URL to the API. Keep in mind, we added our own resource, the simple test resource, which you can see here under stages. If you click on that and then get, you see the actual path you need to use. And if we now open that and enter it in the browser, we see hello from Lambda in the browser. Now, that might not be super amazing from a visual standpoint, but think about what happened here. We never created any server or set up any server. We didn't write a Node or a Laravel or anything else application. We didn't create our own RESTful API in code. We didn't ship our code to any server, and as I said, we didn't configure any server. All we did is we created our RESTful API here, and we could add, of course, more endpoints and methods, and we set up some on-demand code in Lambda to execute. And this is what we're using here. Now, in the next video, I will also show you how you can actually reach out to that API from your own application. So from a single page application in this case. But the core features were shown here, or the core idea. We have code which is executed on demand, and the huge advantage is we only pay when our code runs. We don't pay any overhead capacities. We don't have to make sure that we update our operating software on the servers or any other server software. And we get all the security we would have to manage for our own servers built in. AWS is managing our server here in the end. We're just deploying some code. Now, there is way more to serverless development, and there are other useful services you can add to the party. For example, a serverless database. As I already mentioned, check out my Udemy course if you want to dive super deep into that. In the next video on YouTube here, however, I will also show you how to connect this RESTful API you created here to a single page application. Hope you enjoyed the video. See you in the other videos. Bye.